Hi, I'm a housemate again. Today I'm going to tell you something about this Heatmiser floor heat control panel. So this is a control panel control your floor heat on the ground, under the floor, using electricity. So I have this one working fine, and suddenly one day it goes off and didn't turn on anymore. It doesn't turn on anymore. It goes 40 and I try to press it, nothing happened, and I tried everything. The electricity supply is fine, and eventually I managed to take this panel away by unscrewing it from here, and then you can lift this up and see the whole module behind. So I'm Houseman. If you like this video, please stay tuned and watch it to the end, and give some comments below, and please hit the like as well. And if you find this is useful, please share with your friends. So today I'm going to take this out and repair it. Of course, diagnose it and repair it to put it on here. After that, it will work fine. So let's go. So after you unscrew this, you can take it out by tilting up and take it out. You see the panel like this. Usually this one works fine, and behind that this is power supply module. So you simply take this to screw it out, and you find some wire behind, and obviously it's not very difficult to take it off. After removing the front panel, I put tape on individual wire, so put them separately, individually, keep them separate, not touching each other. Also, I put a bigger tape to cover this hold, so when you touch it, you don't get an electrical shock, and also don't make them in the shock circuit. The wire in the socket with 3 wires, with the brown one and the blue one is live, neutral, and a gray one. The gray one is the connection to the boiler. So when you have this repairing, if you're brave enough and you are knowing what you are doing, you can bypass it by putting the live wire to the gray one, put a switch there, or even you can connect together so you activate your floor heat without the control panel. I will explain why in a second. The wiring diagram on this Heatmiser is to have the of course the live and the neutral to provide the power on this unit, and the live will have the little wire connect to A1, and then you will have the gray color, which in my case, or different color in your case, connect to A2. Because A1, A2 is a switch which is in a relay. So if the live wire goes here, if A1 and A2 connect each other, simply 230 volts will go through A1 and then come up to A2 and into your boiler. So if you want to skip this one, you simply put the live wire, connect to the gray wire, which skip this whole unit, and skip the relay switch inside to have your floor heat turned on without any temperature control. On the internal diagram on the other side, when you flip it over on this one, you will simply see the live and the neutral supply this unit, and the live and A1 connect each other in this one, and actually on the diagram is here, which is the part of the relay. The relay core is here. When there is a certain voltage, I believe this less than 30 volt, which is printed on the relay. And when you have the voltage here, the switch here will be closed. So the electricity from L, which is connected A1 already, go through the switch, come out to the A2 to your boiler to tell your boiler to switch on the floor heat. So without this one, you will skip it, L to A2, which is equivalent to here. You will put the L to A2, which is the brown wire connected to gray wire, and then this your floor heat will turn on when you are doing the repairing job here. What I have set up on the table is the good panel on the left and 41 on the right, with the power supplies on both wire to the power supply under the table. So I go to side by side to make a measurement with the multimeters on each point I want to measure, and record down all the voltage, all the resistance on a separate sheet on the left for the good panel. On the right is the 41. Also this panel, the front panel, I put it aside, which if I can use it to investigate further. This is the record sheet on the 40 panel. There are resistors number 6, number 2, and number 1 here, and resistor number 3 and 4. And look down the rated resistance, and actual one, all the resistors are good. On this part is a chip LNK 564 PM, which is 8-pin IC for the power supply. I searched the schematic, also the pin out from the internet datasheet, and then there are 4 sources here: BP, FB, and drain here. The rated FP is 1.69 volt. However, on this 40 panel on the right, it only gave me 50.7 millivolt. It means nothing. The BP 5.8 volt, it gives me 5.84 volt, all compared with the source. The drain one, it gives me 324 volt. The good panel on the left gives me the FB 1.701 volts, which is good. The BP 5.84, which is very good as well. And the drain gives me 324 volt, which is also good according to the data sheet. So I'm going to measure the voltage between this source. There's a power chip here, the source one of these 4 pins, and also the top right pin, and then I compare with the one on the right, the source pin here, and also one of the pin on the top right corner, which is the top right corner is the FB, so read 1.69. However, you will see the 41 only have the millivolt. So let's monitor this meter. So I'm going to measure the one on the left, the good one. Alright, that's 1.71 on the left. And then the right one, it's only reading 50.9 millivolt and not very steady. So there's a problem on the chip. The other one I find is the this chip, this dial is burst or faulty, I would say, that this have no potential between making up all this area have a zero voltage. What I'm going to do is to measure the voltage between this dial on the right, the same this dial. So this dial is called SS210, which is a one of the very common dial which is used in all other electronic board. So I'm going to have this measurement on a good one. -12. Maybe I reverse them. The good one with 12.1 on the right. It is 0. So obviously this area reading 0 volt, which is not very good, and there is a capacitor underneath this chip, these 2 pins, and on the right there are these 2 pins. So the one on the right is positive, so read some voltage, I guess, maybe the same, 12.1. So let's use that. Let's go for maybe I'm measuring the capacitor using one of the ground pin, and this pin that's showing me 12.08 on a good one, and on the 41 the reading is 0. I've checked the capacitor on these 2 pins. The capacitance is good, only this dial makes a problem. I think it doesn't give this function to this area. And there is a 3 pin, it is a transistor underneath. So with this pin attached to that, I suppose it all reads 0 as well. The middle one, and also the middle one is ground. Go to this board. And the right one maybe you should read some voltage. So let's go for the comparison. With a good motherboard like this, on the left you can compare them, it's make your life easier. So I go for the one of the top pin. Give me 12.07 on the good board. Right, middle one is the same as this ground, so it is 0, and the last one reading 4.91 volt. Alright, it's a good one. So 12, 0 and 4.9. And the 41, the top pin on the transistor reading, alright, let me fluctuating reading, I think is 0. The middle one's to the same area, same ground area, so I suppose it's reading 0 as well. And on the lower one, reading absolutely 0 as well. So on this area, because it's dial problem, all this area give me 0 reading. And on the left area, this RNK564PN, the FB pin, the voltage is not good on the 40 board, so I reckon I need to change this and also this dial. I'll prepare the transistor here as well in case I have to replace it. Just to make sure I've done it. So I want to show you how do I know the dial on the right, this dial is not good. So what I'm going to do is to measure the good one and then reverse the LED on the multimeters and then read on from the other side. So I'm using the positive LED on the left and the negative on the right. On the good board it gives me minus 12.07. If I turn it around, give me positive 12.08, and the 40 board the reading is 0. When I turn it around, it reads 0 as well. So the diode is not good. Another method you do is to unplug the power and use the multimeter, the diode function, to measure this diode on both directions, and you will find this one is shorted circuit, so it is reading 0 on both sides of the reading. So I think the analysis is up to here. So what I know is this diode, the 40 board, this diode, and also the chip. We have to change it. At least these two create a problem. So after this has been fixed, I put it back on and put the panel on. Okay, let me switch that on. The lights comes on and it works. Get back to the normal state and it has resetted, and so I have to set it again, and that's good. So you can follow the way I fix it, and I hope you can fix yours panel as well. So basically Heatmiser panels like this, but every other panel, the working principle is very similar. I hope you like this video and you'll find your successful way to do your own. If you like this video, please subscribe it and put some comment below if you have tried it, and share this video as well. Oh, looks good. The memories come back, and the time, the days, and all the settings come back. Oh, that's great. So hope you like this video. See you next time for another project. Goodbye.